Hi everyone, and welcome to the final lesson of iolite's Python for LA-ICP-MS course. This week we are talking about user interface or UI plugins. UI plugins are easily my favorite thing about iolite's Python integration because you can do so many different and interesting things. So let's dive in and see if you agree. An overview for today's lesson is shown here. As before, I'll start by giving you a tour of UI plugins in iolite and talk briefly about why you might want to write your own. Then we'll get into the specific requirements for a UI plugin and talk about some new features that we'll use in today's examples. The bulk of our time will be spent making 4 user interface plugins, each of which will teach you something new, I hope. Then we will finish by talking about this week's assignment. Three different types of user interface plugins can be found in iolite's main window. The first type is a sidebar plugin. So, for example here, any of these icons that appear below the black horizontal line in the sidebar are user interface plugins. So the imaging module is a user interface plugin, the database module, and the Python workspace. Another type of user interface plugin is a dock widget. An example of that is the Python console. So this is a special type of user interface plugin that appears in a widget that attaches itself to the side of the main window or can be popped out and floated. The third type of user interface plugin is just a menu item, and now this menu item might just perform some calculation in the background, or it might open a completely different user interface to do something. So for example, if I come into the Tools menu and go to Calculator, this is going to pop up a dialog to do some calculations, and that is a user interface plugin as well. Now there are a couple of different ways that we do this. So some of the plugins are built in and written in C++. So for example, the imaging plugin was written in C++, while others that are included with iolite were written in Python. So the Refine Selections tool here is completely written in Python. And now you can see a list of all of the user interface plugins by coming to the Tools menu and then going to Plugins and Manage. And if you come into this window here and just leave the user interface type checked, you can get a list of all of the different user interface plugins. So you can see the imaging module here, and you can see the refiner down here, as well as many others. Now, the path that iolite will look for user interface plugins that were written in Python can be found by going to Session, Preferences, and then coming to the Paths section here and looking at the UI plugins path. So right now I have changed this from the default, and I've got it set to a folder on my desktop that we're using specifically for this lesson so that we can start fresh and create some new plugins. Now, to create a new plugin, much like before, we can come to the Tools menu and then go to Plugins and click Create. This will bring up that small dialog where you can create a plugin. And here you would specify a plugin type of UI and then fill out the metadata as appropriate. Now, sometimes when you're working on a Python-based user interface plugin, you'll want to reload your script and reintegrate it into the user interface. And the way that you do that is to come to the Tools menu, then go to Plugins, and then click Refresh. Now, I'm sure that if you've used iolite before, you've used some of these things in the Tools menu, all of which are user interface plugins. And you can probably appreciate that there's a great many different things that you can do with user interface plugins. So from the very complex, like iolite's imaging module, to very simple things like combining laser logs and everything in between. So even Visual Age, for example, is a user interface plugin. Now, why would you want to write a user interface plugin? By this point in the course, you've seen a variety of things you can do with iolite's Python API, and there's even more functionality available that we haven't touched on. A user interface plugin is a way to harness the power of the Python API and present it to the user in an easy-to-use interface. Basically, if there's a feature you would like to see in iolite that does not fall into one of the other plugin categories, like an importer or a QA/QC module, especially if it is somewhat unique to your workflow or data, you want to write a user interface plugin. So here is our overview of a UI plugin Python script. Like the other plugins, it should begin with some metadata. Most of these fields are the same as before, but in this case we must specify the type to be UI. The only required function is create UI elements. So this function creates actions and or widgets and tells iolite how to integrate them into the main window. When a UI script is evaluated, the objects listed here will be inserted for you to use. So most of these you should be familiar with by now, but there is one new one called UI that we'll talk about next. The UI object is pretty straightforward. It has just a few functions, and which ones we call will depend on the type of UI integration we want to achieve. If we want a menu item only, we call set menu name to indicate the menu structure and also set an action to put into that menu. If we want a sidebar widget, we can set the action to be inserted into the sidebar and the widget to be displayed when we click on the sidebar. One or more of these functions must be called in the create UI elements function. There are a few other things that we're going to use in the examples today that I'll just briefly mention. We can get a standard icon by name and set it on actions or buttons and so on by using this common UI .icon function. So this one listed here. And now this icon name should be the name of a font awesome icon. So for example, it could be plus. I'll put a link to the font awesome list of icons in the documentation. We will also use some new signals today. We have selection changed, which is emitted when a selection is changed, for example, one of its properties or its start and end time. We have active selection changed. Now this is emitted when the selection that is active changes, which is different than above. So this is, telling you when the selection that is red is changed, for example, in the time series view. Then we also have active selection group changed. So this is emitted when the group that is active changes. So if you click on a different group in the time series view. And then we'll also create some of our own signals using this signal name imported from iolite.qt core. For one of the examples today, we're going to use something called Qt Designer. So this is a way to create a user interface with the buttons and combo boxes and whatnot in an interactive way. So if you would rather build a user interface graphically rather than programmatically, Qt Designer can be used. So normally it's a program that comes with a full installation of the Qt SDK, but this is a rather large download and is not required in its entirety if you just want to make a user interface. So a standalone version of Qt Designer can be downloaded from the URL shown here, and we will use this in one of our examples so you can see how it can be done. Now, as I mentioned, I really like user interface plugins, so this made it hard for me to choose just one example to implement, and so I decided on 4. For our first example, we're going to just create a menu item with a shortcut that is used to run a Python script on the active selection. For our second example, we'll use Qt Designer to build an interface for a live cloud type of plot. So this plot will be it will respond to changes in the active selection, kind of like Visual Age, but will look more like the raw image inspector that we have in our imaging module that shows the data plotted as individual time slices. So for our third example, we'll create a custom widget that draws each selection in the cell and shows the image log image if available. So this one will be a doc widget and will provide some spatial context for the current group and selection. And then lastly, we'll create a sidebar example where we'll use a periodic table to select some elements, and then we'll display some reference material data for reference materials that match the selected elements. Okay, so let's get started. Okay, for our first example, we want to create a menu item that has a shortcut that will run some script for us. on the active selection. So to get started, we'll go to the Tools menu and then click or go out to Plugins and Create. And now I'm going to set the type to UI. The name will be Active Split. Description will be Splits the Active Selection. And the author can be J. Petrus. And I'll say OK. Now I've got this active split script here that I'll bring up. So all of the metadata has been transferred over from the dialog already. I'm not sure if that's a good size there. I'm going to just remove some of these comments because I like my scripts to be nice and little. Now I can remove some of this stuff that comes from the template. So we have this summarize function that we're not going to use, so we can get rid of that. And now I can also get rid of all of these comments. So the first thing we have to tackle is the create UI elements function. So we will be creating an action. That action I will call active split. Or this is the name that will end up in the menu. Maybe we'll call it split the active selection. And then we'll also tell it, we'll put none here. And now when that action is triggered, we're going to call our function, which will be split. So down here we'll define another function called split. And print split called. So when we test this, it'll print split there. So the action is connected up so that we'll call that function. And now we can set the action to be action and the menu to be in tools. So what I was thinking here is that rather than just be in tools, I could do something like this, where I put it in tools / Joe's scripts. Now let's just save that and return to iolite and go to refresh the plugins. And now we should see Joe's scripts and split the active selection. And if I click on that, you can see that it is print split called. So far, everything is working as expected. So let's return to our code right here. And now we need to actually do something when we call that split function. So what I was thinking was I had this note from a long time ago where I wrote a little example of how you could split a selection into several sub-selections. So I'm just going to copy that code out, and I'm going to paste it in here to the split function. Okay, so we just need to fix the indentation on all this stuff. So I'm just going to grab it all and indent it. So you can see that what we're doing here is we're getting the active selection from iolite and assigning it to S. And then we're doing a, we should add in some extra things here. So now if S is none, we can do a message box, and this takes a few different arguments. The first is the parent, which we will do none, then the title, and then the message. So we'll say there is no active selection, abort. Okay, and now we need to do the destination group. So we're going to create a selection group. I think I want to change this because so we'll do something like s.name and then split and then and we'll take this and we'll put this here, and I think 20 might be a little too much, so let's change this to split it into 10. It's going to be of the type sample, that's fine. And then we're also going to add true to the end here. Now what that true argument's going to do is it will replace an existing selection group of that name. Okay, so now I'm going to assume that this is still correct. So we're calculating the duration of our selection. So we're taking the end time, converting it to milliseconds since the epoch, and then subtracting the start time, and that's in milliseconds. So we're dividing it by 1000 to turn it into seconds, and we're also multiplying by n. So this in the denominator, so this will be the duration of each sub-selection. And now we've just got a little loop to come through and create each sub-selection. So let's save that and see how it works. So we'll come back to iolite, we will refresh the plugins again, and then come to Joe's script and split the selection. Okay, so that part works. So I activated the script that way, and I got, there is no active selection abort. So that is good. So if I come here now, and I just pick something. So we've got an active selection. So now if I go to Tools, Joe's Scripts, split the active selection, you'll see that I now have a NIS 610 5 split 10. And if I go to it, you can see that it's got 10 sub-selections that were equally split from that original selection. So that appears to be working as expected. So I'm just going to remove that group for now, and we're going to go back to our script and add in the part that really makes it handy. So we'll come back to our script, and now back up here where we've created the action, what we're going to do now is we're going to set a shortcut. So to do that, we can do action.setShortcut. And now what's expected here is a Q key sequence. And we can tell it what the key sequence is that we want it to be activated by a few different ways, but the way I'm going to do is to just write it in text, and I can say Alt+1, and now our shortcut, oh, I've misspelled this here, set shortcut, yes. And then the other thing we need to do is we need to import Q key sequence, and we can get rid of some of these other things that we're not using. Are we using NumPy? No, so we can also get rid of NumPy. Let's save that and now see if our shortcut works. So we'll go to Tools, refresh, and now if I come here and I select this, now if on my keyboard, if I press Alt+1, nothing has happened. Tools. Uh-oh, there was an error. Okay, let's have a look here. So there was nothing printed there. Let's just refresh our plugins again. I think the problem might be that the Python console is loading after it. So we've got an issue in our code. Let's pull it up and see if we can figure it out. Action set shortcut Q key sequence. Looks right to me. Aha. Okay, so it looks like this is what's happened. As you may recall, Python is very particular about the way that things are indented, and it's not immediately obvious here, but the original lines of code that are here are indented with spaces, and the new line that I've added is indented with a tab, and it's not going to like that. So I'm just going to re-indent those using so that they're all done with tabs. Now let's come back to iolite and refresh, and now, yes, you can see that we're back in business here. You can see that the action now has its shortcut listed in the menu, so Alt-1. And if I'm in here, I should now be able to press Alt-1, and yes, so when I did that, our selection was split into a new group containing each of the subselections. So I think our mission is complete on this particular user interface plugin example. Okay, the next example we're going to look at is creating that live cloud dialog. So we were saying that we were going to do that using a program called Qt Designer. So what I've got here is Qt Designer loaded up, and this is roughly what it'll look like depending on whether or not you are using it on a Mac or Windows. But this is the new form wizard that comes up on startup. And what we're going to do is select widget from the template and then hit create. And now we've got this window here that we can add different widgets to graphically. So if, for example, if I wanted to add a button, I could just drag out a button from this side, and there's my button. And I could click on it, and I could say, I could change the label on it. And then over on the right-hand side, I can change a whole bunch of different properties about it, like the size and whether it's checkable and the style and things like that. Another thing that you'll need to pay attention to is the object name. So the object name is really important because that's how we're going to get a reference to it in our Python code later to be able to interact with the different controls. So let me just delete that. And now what I was thinking for this particular example was that we would need to be able to select an X and a Y channel. So to begin, let's start by putting a label. So you can type into this box up here in the top to filter the different widgets. So if I want to get a label, I can start to write label, and I can drop in a label, maybe another label, and then I'm also going to want to get some combo boxes. So I can also place those in. Now I could set that to be X channel, and I could set that to be Y channel, and I could put these roughly in line, and then I'm just going to select all of these things and right click on it and say layout horizontally. Okay, so now I've got these things laid out in a horizontal layout, the same way that you would do a horizontal or an HBox layout in the code. So next I'm going to add a frame. Now we can't add iolite plots and things like that in the designer because the designer doesn't know about any other widgets that we've created. It only knows about the ones that are built into Qt. So I'm going to just add this frame in the middle here without anything in it, and I'm going to add my plot to that frame after. So we'll just leave that called frame, but we better go back and at least name these things. So I'm going to give this one a name of X combo box, and I'll name the other one Y combo box. Okay, naming the labels is less important because we're not, unless we want to be able to get them in our Python code and do something with them. And then I also want to put some options along the bottom. So I'm going to do a couple of checkboxes and a couple of buttons. So I'm going to search for tool button. I'm going to drop in a couple of buttons. So this checkbox will be to keep the range fixed so that the range of the plot isn't always changing as you adjust the selection, because if the plot ranges update every time you adjust it to the minimum and maximum, it's hard to keep track of how the data are changing relative to what they were previously. So I think that that's a useful option in this type of plot. And then we'll also have an option to show the group. Okay, so, and then this button will be a button where you can choose a selection color. And this button will be for choose group color. And now we're going to lay out these controls again in a horizontal layout. So we'll select them and say to layout horizontally. And now we can lay out the main widget by going to layout and do layout vertically. Now, this doesn't look great just yet. We're going to do a couple things to make this a little bit tidier. So there's a thing in here called a spacer. So we can drop in a couple of spacers. So I'm going to put a spacer here, but also at the end. And I'm going to limit this one here. So instead of being expanding, it's going to be fixed. And we'll just keep it fixed at, say, 20, just so there's a little gap between the two of them. And I'm also going to come to this frame widget, and I'm going to change its size policy from preferred to expanding. And you can see that this is starting to resemble what we would want our dialogue to be. So the only other thing that I'm going to do at this time, well, first of all, let's make sure everything's labeled appropriately. So the spacers don't matter. The combo boxes have been labeled. Okay, we need to label these. So we're going to do, we'll call this one fixed range checkbox. And we'll call this one show group checkbox. We'll call this button, what is that? That's the selection color button and group color button. And we'll also give a name to our overall object. So we'll call this live cloud widget. And I think that's pretty good from the object naming perspective. The only other thing I'm going to do is I'm going to, where is it? So if I scroll down to the bottom here, you can change the margins of the layout. So I'm going to make it so that there's a little less space around everything. So it goes a little bit closer to the window border. And one last thing that we didn't do. So on the main sort of widget, we can find the window title property here, and we can call this live cloud or something like that. Okay, so that's our widget. So we're going to save that, and we're going to save it right in the folder that we're loading our UI plugins from. So we'll just call it live cloud, and that's a .ui file, which is I think just a bunch of XML that Qt can then load in the code. So we'll save that. So we've got our user interface created. This wasn't a terribly complex user interface, so it wouldn't have been that difficult to make it in the code. However, for more complicated interfaces, it can be really nice to do it graphically like this. And it's also just handy to see visually what's happening and where things are, and if you really want to make a nice interface. So, okay, so that step is complete. So we've saved that, and we'll close that. And now we'll come back to iolite. So we're back in iolite now. And we're going to go to Tools, Plugins, Create. We are going to create a UI plugin called Live Cloud. Description, live plot of active selection. Something like that. And we'll open it. Okay, so as before, I'm just going to clean up some of these comments. You can get rid of some of this stuff. We can get rid of this function, and we can focus on what we're really trying to do. So our action can be called live cloud, and we'll connect that action to a new function called create live cloud, I guess. And so we'll come down here and do create live cloud. And this has changed again. So we want to make sure we're using the right tabs and spaces, so we don't have that same problem as last time. Okay, and we're going to put that right in the tools menu. So I think that's probably fine. We're going to do like we've done sometimes in the past, and we're going to create a global widget. And now down here we'll go global widget. And that widget can be live cloud widget. So we will also now need to create a class called live cloud widget, and that will be a QWidget. Okay, and then here we will also do our widget set attribute qt.wa delete on close and widget.show. Let's just make sure that we've imported everything we need. So we need to bring in QWidget, and we'll need to bring in a bunch of other things later. But for now, just to get things off the ground, we need Qt, QWidget, QAction, and that should be enough. So let's just see that that part is working. So we haven't loaded our user interface yet. So let's come here, we'll refresh. We've got live cloud in the list, and if I click it, we've got an empty widget. So far, so good. It's not actually doing anything yet, but that's okay. So the next thing we're going to do is get that user interface loaded. So the way we do that, so first of all, we're going to need to set up a layout on our widget here. So we'll do, we'll get a QVBox layout, we'll import that, and then we can do self.setLayout QVBox layout. And what I'm also going to do, since we're bringing in that user interface that we created in Qt Designer, I'm going to set them. We're going to set the content margin. Set contents margins. I think that's what it is. I'm going to set that to be 0 in this case because I don't want this layout taking up any space. I want it to be only what we created in Qt Designer. Okay, so the next thing that we need to do is a little bit of code to figure out where to load that UI file from. So we're going to bring in next is QSettings, and we'll do settings equals QSettings. And now our UI plugins path we can get from the settings by doing something like this, UI plugins path. And now our UI file is going to be, we can do a Q file, and that'll be UI path plus livecloud.ui. So we need to bring in a couple more things. We need Q file. I guess that's it for now. The other thing, what we're going to need next is from iolite.qtui tools, we're going to import something called QUI loader. So now we can do loader equals QUI loader and do loader dot load UI file. And we can set that to self.ui, self.ui equals loader.load file. And now we can do self.layout.add widget, self.ui. Let's see where that gets us. Cloud, okay. So you can see that it's loaded our user interface and all the controls that we created are here. We haven't connected them up to do anything yet though, so that's our next step. We also need to get a plot into that frame. So first things first, let's get all of the controls that are relevant. So I can do a self.x combo box equals self.ui.findChild, and it's going to be of type QComboBox, and its name is going to be QComboBox. So we need to import QComboBox, and I think that's, what else are we going to need? We're going to need QTool button, and QFrame, and QCheckbox. I think that'll be it for now. So let's get the rest of them. So it is a little bit of work just to get everything plumbed in here after the fact, but depending on how you think and like to work, this might be easier for you to make a user interface. This way. Okay, we can do a what do we need to call it? Fixed. Is it fixed checkbox? And self.showGroup checkbox. Can't remember if these are the names for sure, but we'll find out soon enough. And self.selection, color button. I should have left that open so that we could check, but it's all right. Okay, I think that's all of the different controls. So now we have a handle to those in the code here. So we could do something like, maybe we'll set it into an UI type of thing. So we'll create a different function. Oops. And we can do self.xComboBox.addItems, and we will add, I guess we could add all of the time series names in case you wanted to plot an input channel, so we can just do something like that. Let's just see where we're at, because we may have gotten some of these names wrong, so let's fix that before we get too much further. So refresh, live cloud. Okay, so we've got that far, but let's just see, and there was no errors, so maybe we did do all right. One thing I wanted to check though was in here. Yeah, okay, so all of our channels are in there. Good. Okay, so we're going to need to add a plot to that frame. So we can do self.frame.setLayout q vbox layout. And then we're going to need to create a plot. So we'll create it with the parent of the frame. So we need to come back up here and do from iolite.ui import iolite plot by interface as plot. And then we can do self.frame.layout add widget self.plot. And we'll do, we're going to resize this window by default because it's a little bit small. Let's see how that worked. Oh, we have a problem. Okay, so self.frame, the frame, self.frame, find child. Oh, I wrote the wrong thing here. It was supposed to be just frame. So let's refresh again. And live cloud. Okay, so we're getting closer. So now we've got our plot in there and the window has been adjusted slightly in size to something a bit more useful. So let's close that and go back to the code. So that's working now. Okay, so let's connect up some of these controls so that they store their settings, and then we'll create a function down here called update plot that eventually we'll want to get to, that will actually plot the data. And we'll create another function called update setting, value, something like that. But we'll also now need to do stuff like xcombobox.activated. Let's do text activated, activated, and we'll connect that to self.update setting, and that setting is going to be X channel, and the value will be T. We'll do the same thing, for the Y channel. And we'll do the same thing for fixed checkbox.checked, I think. Fixed. There's a typo here, update, and that will be show group. And okay, and now we need to actually do something. So we're going to do something a little bit different. We're going to call set attribute of self, and we'll set the name and value like that. Okay, and then we'll do self.update plot. So that means anytime that we update a setting, we're going to update the plot, which probably makes sense. Okay, the other thing we could do is connect up those buttons. So self.selection color button clicked, connect self.get selection color, group color button clicked, connect self.get group color. So we'll need to come down here, get selection color, and we'll do color equals q color dialog dot get color. And then we can do update, or we'll do self.update setting, and that will be selection color. Let's see. We'll do the same thing for get group color. Okay. Let's just try to run that and see if we get any errors. So there was a problem. So fixed checkbox. I'm going to guess that we didn't get the name for that right. So I'm going to pull back up Qt Designer. Gonna load up our live cloud. What did I call it? Fixed range checkbox. It might be fixed range checkbox. So we come back up here, fixed range checkbox. Let's see if that fixes it. Nope. Oh, right. That is not a signal. So down here I did checked, but checked is not the signal. I think in this case we can use clicked, or you can use, I think, toggled. Let's try that. Okay, so we're back in business. We've got the plot. Let's close that. No errors. Let's carry on. So we should probably also initialize some default values. So let's do self.xChannel equals data.timeSeries names. Take the first one. Show group can be false. Selection color can be cute.blue. Red, I guess. Fixed, is that what I was calling it? Yeah, fixed show group. So fixed will be false. Okay, so we've set our default settings, we've connected everything up. We could probably do a very basic version of this now. So let's come here. So what do we can do, we can get the active selection. So for starters, we can, yeah, well, we'll do self.plot.clear, our clear graphs, just to clear everything for now. We'll come back to that a little bit later, but if s is none, we're going to return. But we can do a g equals self.plot.addGraph. And we can do g.setData, and then we're going to have some x and some y data. And then we can do self.plot.rescale axes and self.plot.replot. So what is x going to be? X is going to be data.timeSeries. So we're going to get the time series of our x channel. And we're going to do data for selection, and the selection is going to be S, and Y is going to be data.timeSeries channel data for selection. Yes. So that should give us some very basic plot now, I think. So let's see what happens. So we don't have an active selection just yet. So let's come in. Oh, and we're not responding to an active selection. Okay, so you can see that it is updating, but we've got a couple of problems. So the first thing that we need to do is, first of all, let's change it from a line graph like this to just be markers. We need to make it so that the window stays on top. And we also need to have it respond to the selection being changed. So let's do those things now. So since we're here, we can do g.setLineStyle, and we'll set it to be none. And g.setScatterStyle, I think. Yeah, and then we can do disk. We can say the size and the color. So we'll do selection color Okay, that'll be that. What were the other things? So we want to have the window stay on top, right? So the way that we can do that is we can come back up here and we could add in a line that does something like self.setWindowFlags, and then we can do cute.windowStaysOnTop That ought to do that. Now we can add in another connection here where we do data dot selection changed connect to self.updatePlot. I think that should do it. We'll find out in a second. Okay. Okay, so you can see that it is working. We can change that and we can have it update as we shift around. Great. So we are making progress. Let me just try to, so you can see that, you know, it's responding to the active selection being changed. It's not responding to that though, so we need another check. So that just means that we need to also update the plot. So we can do data.active selection changed. Okay, so what should we do next? One thing I noticed is that we could also set window title. Okay. So we have a few features that we had in the user interface that we're not doing anything about yet. So fixed range. So if if not self.fixed, we'll rescale the axes. So that takes care of that. And then show groups. So I think what we'll do is we'll refactor some of this out and we'll create another function called plot selection. Sorry. So we will do this again. So basically can grab pretty much all of this code is going to go in here. So we'll get the X data. This is now cell. It should work. That should be fine. And then the only other thing that we're going to do is do self.plot dot, or no, not self.plot, we'll do g.setLayer layer. That way we can plot the group, and the active selection on different layers and using different colors. So I think that's fine. So now we would want to do something like self.plot selection data.active and maybe we should active so be more specific here with our names. We can plot the active selection. We're going to give it a color of self.selection color. And we will also do the layer can be called selection. Now we should, when we create our plot, we should probably do self.plot.addLayer selection. and self.plot.add layer group. Now, rather than doing clear graphs, we can do clear layer selection. Let's see if that's getting us closer. Oh wait, we haven't done the plotting for the group yet. So let's see if we do if self.showGroup, then we will go for if self.showGroup, yeah, okay. So if we should have an active group by the time we get here, because if there's an active selection, then there's an active group. So we should be able to do data.activeSelectionGroup.selections. And now we can go self.plotSelection. That do self.groupColor, and we can do add that on the group layer. And so that should work. Let's see. Okay, so if I do fixed range, let's see. Okay, fixed range is working. You can see that it doesn't change the range that we're plotting. So now you can see how it's shifting relative to where we started. That's good. And now if I do show group, okay, the only problem now is that we are plotting the group after the active selection. So you can't see where this selection is plotting because all of that is on top of it. So let's go back to the code and we will do this part. Oh wait, we are plotting that part after. What's going on here? Okay, it's not clearing the plot properly. Okay, because we also need to... Right, so we probably don't want to replot the group every single time because that's a lot of data, and we only really want to replot the active selection. So we're going to change the way this works a little bit. So we're going to keep track. Let's use, so that's going to be that. And we're going to say, well, we'll still do that at some point. Let's just we'll try. So when we do, we're going to do self.plotted group equals none. And here, whenever we update the setting, we'll set plotted group equals none. Okay, so now if we are updating the group, or we're not showing the group, then we're going to do self.plot.clear layer. So that'll clear the group layer. Okay, it's just gonna come down here somewhere. And now we want to take this. So now we want to do if show group and update group, and group is not none. Then we want to update the group, and we're going to store which group has been plotted. So we're going to do plotted group equals group.name. Okay, I think that should work. And now let me just make sure that the rest of this is good. So every time we run this, if we've made it this far, we're going to want to clear the selection. And if it's not, could do maybe what we'll do is we'll go if active selection, then we'll plot it. We can do maybe we should just see where we're at now. Okay, let's see where we're at. So let's close that down, refresh. And there's still something not quite right here. Got an idea. Yes. So I think because we're adding the selection layer first, that is controlling the Z order, even though we're technically plotting the selection after. So I'm just going to take that, pop it after group, and let's see if that fixes the order that things are plotting in. Let's go. Yes. Okay. So now you can see that the, whoops, let me bring this up here so you can actually see it. So now you can see that we have the current selection in blue plotted on top of the group, which is in red. Okay, and if we take that off, that's good. So that's working. Fixed range, let's see. So if I take that off, fixed range is working. Show group is working. Let's turn off fixed range. Okay, one thing we haven't tried yet is actually changing the colors. So let's see if I choose selection color. Okay, that didn't actually do anything, so that's not working at the moment. Let's see what happened. Oh, I just haven't imported QColor dialog. So let's go back here. We got to bring in QColor dialog. Save that. Back to iolite. Bring this up here. Show group. Pick some more useful channels. Okay, and now change selection color. All right, so I've got this color picker now that comes up, and let's turn it into a green, maybe? Right, so you could see that that changed. I could change the group color as well. Let's change the group to something there. Maybe change this to be red. Okay, so that's working. Well, I think everything's working. Oh, one thing we haven't done is set the X and Y labels. That's something that you've probably done a few times by now, but I'm just going to do it for completeness. So let's come back in here. Could clean up some of this a little bit. So I would just do a self.plot dot left dot set label, and that will be our self dot y channel, and self dot plot dot bottom set label self dot x channel. Okay, so I think we've we've completed everything that we set out to do, so that's where we'll end this example and move on to the next. Okay, for our next example, we're going to create a sort of cell view style dock plugin. So this is going to take the coordinates of our selections, if we've created them from a laser log file. It'll take those coordinates and draw them into a representation of the cell so that we can see where our current selection is relative to other selections spatially. And also, if an image log has been used or was found when doing the laser log import, we'll also show the image that goes with that selection. So in Python, we can get the coordinates of a selection by doing something like this. So if I go data dot selection group, and I take a group and I get a selection from that group, and then I do a property, I can do coords, and this is just now here a tuple of q point f's. So these are the xy coordinates of that selection in micrometers in cell space. So we can also get the image that goes with that sample using the image property. So using that little bit of knowledge, we can create a visualization that shows where the active selection is in the cell and relative to the other selections in other groups. Okay, so let's get started. So we'll go and create a new plugin, UI type, we'll call it cell view, plots selections in cell space. Right, so we will get rid of the boilerplate and comments. Delete this. Our action we will call cell view. When it's, wait a second. No, if we are creating a dock, we don't need to create an action like that. So we're going to do things a little bit differently. Let's just delete all this and start from scratch. Oh, again, I got to change this. Using tabs. Okay. So what we need to do this time is we'll do dock equals q dock widget, remembering that we need to keep that dock widget imported, and it's going to be called cell view. Then we can do dock.set object name cell view dock. What we need to do, so we're going to need to do dock.set widget. So this is setting the widget that's going to be displayed as part of that dock, but it'll, by making it a dock, it has that functionality that allows it to attach to the side of the window and so on. So we're going to do something like this. Cell view, and its parent will be dock, and then we can do ui.setDock dock and ui.set menu name to be in the tools menu. But we now need to have a class called cell view that is a Q widget. Okay, So let's just save that and make sure that that is working. So it isn't. And that's because I haven't imported QWidget. I think. Right, so now we have cell view here. You can see that there's a little thing to toggle it. So it can show up as a doc now, but we of course aren't actually doing anything with our widget, so it's just empty for the time being. Let's go back and change that. So we're going to need to know what the overall dimensions of the cell are. In this particular cell was, I think 100,000. And we're also going to do data.active selection changed. We're going to connect to that signal, and we'll connect that to self.repaint. So that means anytime we change the active selection, anytime we change which selection is active, it will automatically repaint. So what we need to do now is define a paint event. And that means that we're going to need to do, use a Q painter again. And we're going to paint on self, so we need to bring in Q painter. We are going to do some things that we did in the past, so we're going to set the render hint to be Anti-Aliasing. Now, what do we need to do here? So let's see. So we would like to draw So first, let's draw a rectangle that represents the cell. So let's start by trying this. So we'll do event.rect. Wait, we can't do that because the event.rect will be the rectangle for the whole widget. So we actually need to so let's do an adjustment on that. So let's do prect equals event.rect adjusted. So we'll bring this in just a little bit so it doesn't take up the entire thing. It doesn't go right to the boundaries. And then we're going to need to do something like this, where we set the height depending on, so we're going to take the width of that and then multiply it by self.cellSize. So because we want to take into account the aspect ratio of the actual cell. We don't want to just draw the rectangle to match the shape of the widget. We want it to match the shape of the cell. So we're going to do something like this. Now, if we'll set a pen here, and the pen, we'll just do white to start, I guess. Actually, let's give it some width though. So we'll do QPen. I think we can do something like this to make it a bit heavier. That means we also need to bring in QPen. Okay, so now if we do a draw rect and we do as our prect, let's see if that works. It does not. Oh, and that's because I have not brought in Qt. So let's do that from iolite.qtcore, import Qt. There. So we've got a rectangle that represents our cell is now drawn in our widget. So let's go back to our code. Now, what do we need to do? We want to draw, so we want to iterate through every group and go through every selection in the group. And then we want to draw an ellipse or a rectangle, depending on if the spot is a slit or a circle. So let's start by putting these loops together. So we'll do for group in data.selection group, and we'll do data.sample data.reference material. So we're not going to bother with backgrounds. Oh, this should be selection group list. Then inside of here, we're going to want to do for selection in group.selections. And now we can get start point equals cell.pro, or actually we should probably do something like if cell.properties, if, so we can do if chords not in cell.properties continue. So that'll just skip this selection if it doesn't have coordinates defined. And then we can do start point equals cell.property chords. We'll take the first one for that and the endpoint. Chords. Okay, now these are going to be in cell space coordinates, and we need to translate that into what it's going to be in our widget in pixels. So let's work out a scale factor. So what is the scale going to be? So that's going to be, so we could do something like scale is, we're going to wrap this in a float. So we'll do prec.width. That should tell us our scale. So that's telling us the width in pixels divided by the actual cell width. And that should tell us how we need to scale things. So now I need to keep in mind that we also adjusted our rectangle by 5. So we'll need to shift all of our points by 5 as well. So we can do start x is the start point dot x times the scale plus 5, and then we can also, you know, do the same thing for everything else. Now I've included the endpoints as well, because I guess whoops, if these were actually lines, which they aren't in this case, if they were lines, we could do some, we could add some drawing code as well to draw them as lines. I'm not going to worry about that, I don't think, for this example. Now we're also going to need the spot width. We can get that as well from the selection properties. So the property here would be spot width. And we're going to also multiply that by the scale and the spot height. Okay, and now I think what's going to end up happening is that because the cell is so large, and when we our scale factor here is going to end up with things being smaller than an individual pixel. So what I'm going to do is I'm going to say if the spot width is less than 1, let's set the spot width to be 1. That way we won't end up with things that are too tiny to see. We'll do the same thing for the height. Okay, so now we should just be able to do something like draw ellipse, and then we're going to do it at the start X, but we need to subtract the spot width divided by 2 because this is the coordinates we're providing here for the top left corner. So we need to adjust for the actual size of the ellipse if we want it centered at those coordinates. So we'll do something like that, minus spot height. So that's the coordinates that we want to draw the ellipse at, and then we also need to specify the width and the height. So that should draw it, and let's just give it, some set, let's set the brush, something like that. Perhaps we should also set the pen. Okay, so let's see. Let's see how that works. Okay, so I have a typo here, right? So I've misspelled property. So let's go back. Yeah, property. Let's see if that fixes it. We need to bring in QBrush. Okay, so I think this will come through in the in the recording. So now you can see inside the cell that I've got a red dot drawn everywhere that I have an analysis. So that's looking very good. So now what I want to do is I want to change it so that the active selection group has a different color and the active selection has a different color, and maybe also put a crosshair or something like that. So let's come back in here. So let's do if the active selection group. So if we have an active selection group and active selection group dot name equals group dot name, we'll set the pen to be green and 1, and we'll set the brush to be a green brush. Else we'll set it white. Okay, so that'll change that. So that means down here, what I want to do is only, so I'm only going to want to change this color. Only going to want to change this color here if it's the active selection group. So we can do just if data.active selection and now we can't compare them directly, so I'm doing something like this where we compare the unique identifier of a selection. So that means that this is the active selection. So in that case, we'll set the pen, draw the ellipse, and then we're going to also set the pen to be to draw some crosshairs. So we'll do we'll still keep it as red, but we'll set it to be a dashed line, so that we can do just like that, and then we can do p.drawLine, and this will be at the so we can we'll go with that X, and we'll go from the prect top to the prect bottom. So that will be our vertical line, keeping the X constant, and then we'll do another one where we do prect.left and y, and prect.right, y. Now what I'm going to do here is I'm going to do we can call this painter.save and painter.restore to allow us to change some settings on the painter and then go back to the settings from before. Okay, let's see how that looks. Let's come in. So it looks like it's not drawing everything. It's only doing the active selection. So I've made a logic error here where I'm now only drawing the ellipse. Maybe what I'll do is I'll bring that out. I'll bring this out, do that no matter what, and I'll draw just these lines. So we'll take that out and we'll do it like that. Let's see if that works. Okay, so now you can see, probably be better to show this with the, if I come down to the samples group, you can see that as so right now I'm just moving through the selections by using the arrow keys in this list here, and you can see that as I go through them, my crosshair is changing and telling us where in the cell that analysis is occurring. So it seems that that is all working fine. Now the other thing that we wanted to do was to show an image if there was an image log. So let's see about doing that. So I think we could do that in here, where we could do so we want, eventually what we want to do is we want to be able to do painter.draw Pixmap, and then we're going to want to draw it at a point that is can be, so we'll do it at prect.x. That's where it'll start in the X, but then we want to position it so that it's a little bit below the bottom of the cell drawing. So we can do it like that, and then we want to draw an image. Now that image, we'll create a function to do that. So we'll do and this function will scale the image to the width that we want it, so it'll match the cell size. So we'll do Pixmap for selection. We'll define this new function. It's going to take a couple, actually it's going to needs another argument here, and that argument is going to be the selection. We don't need self, we need just selection and prect.width. So down here it's going to be selection and width. So we can get the image file path by using the property. So we can go cell.property image. That should be our image file path, and we can do if not image file, then we can just return a empty Pixmap. Otherwise we can do image equals qPixmap image file, so that will read in the image file into a Pixmap, but we also want to We want to scale it down to the width that we specify. So we'll do image equals image dot scaled to width, and then we'll return that image. So let's start with that and see if that works. It does not. Of course, the common problem is we have not brought in Pixmap yet. So let's do that and try again. Oh, still no. Oh, we don't have QPointF. So that might be one that we need to import here because it's not necessarily user interface related. Okay, let's try one more time. There we go. So now we have the image as well that goes with that analysis. So, and as we come through, you can see that update as we go. We could draw some crosshairs on there as well. So just like we've done in the past, we could create a painter that's going to paint on the image, and we can set a pen. So we'll do, to match above, we'll do the red with the dash line, and then we'll do draw a line 0 image dot height divided by 2 image dot width, and and 0. Wait, what have I done here? This doesn't seem right. What do I need? So this line is going from 0 in X to the width. So this is our horizontal line. Now our vertical line, we want to start at image.width divided by 2, and we'll go from 0 in the height, and we'll go image.width divided by 2, and we'll go to image.height. Okay, so that will draw, and let's save. Look, fresh. So there you have it. And I think that just about covers all the features that I was intending to. Performance seems reasonably good. And that's where we'll finish this example. For our fourth and final example, we're going to create a sort of reference material data explorer type of tool. So let's just get started. We will go to create a new user interface plugin. We'll call it RM Explorer. A new way to view RM data. Okay, so let's clean up some of this stuff. In this example, as I had mentioned, we are going to create as a dock widget too. So we have an example of the final way that you can integrate into the iolite interface. So let's just delete all of this stuff to start. And we are going to create an action. And this will be called reference, or maybe we'll do RM Explorer. So this \n in the middle here is going to cause a new line so that RM and Explorer will be on 2 lines. I'm just not sure that if I wrote it all out, it might be too long of text, so we'll split it like that. It doesn't really matter what we put as the parent for that action, I don't think. And then we'll do action.setIcon. So this is the first time that we've used this icon tool. And the one that I'm going to use, let me see if I can pull it up. So there's this Font Awesome cheat sheet. So there's all of the different icons that are part of this, of which there are many. The one that I am looking for, balance scale. So I'm going to use this one. And what you need to know about the names, I guess, in here is that we don't use the beginning part and the hyphens are cut out. So I'm going to copy that. I think it should be this, and I can drop that. Now the other thing we need to do, we can get rid of some of these things. The other thing we need to do is we need to do from iolite.ui import common UI Pi interface as CUI. I guess while we're here, we can also add this because we're going to need to be able to add a plot later. And we'll come back to that after though. Okay, so, whoops. So that should be enough to get our icon there. Now we can just do ui.setAction to set our action, and we'll do widget equals rm explorer, and we'll do ui.setWidget widget. Now, of course, we need to define what this rm explorer widget is going to be. So we'll need to bring in QWidget. And now what I had in mind here is that there would be three main components. There would be a periodic table that allows you to choose which elements you want to include, and then a table that has the matching reference materials and the concentrations for those elements, and then also a plot that would show that same information graphically. So maybe the easiest thing to do now, so we can start just by, so let's also bring in QVBox layout. We're actually going, we're going to need a few different layout things. So let's do grid layout as well, I think. So we'll start by doing self.setLayout. This one's going to be an HBox layout. And now what we want to do is we're going to have a periodic table. So periodic table widget, and we're going to do self.layout.addWidget self.pt. Okay, so now we need to define this periodic table widget. So that's our first and one of our most difficult tasks. So let's get on to that. So I'm just going to copy this because it's the same thing. All right, so, and this is an example where we're going to do from iolite.qcore import signal, because we're going to have our own signal on this. So our signal is going to be changed. That'll allow us to respond to changes in our periodic table selection. I'm also going to create a little dict here. This is going to tell us which color to make different parts of the periodic table. So I'm just going to copy this from somewhere else because I've already got it there. That saves me making a mistake. But the indentation must match, so I'm just gonna fix that. Okay. Now, what do we need to do here? So this is where we use this QGrid layout. So we'll do self.setLayout QGrid layout. And we'll do, we're gonna have it be a fixed size. That way we can kind of keep it looking like a normal periodic table. And we can also do something like set contents margins, be a little bit smaller than the default, and we'll also keep track of which elements are selected. So now we need to make a whole bunch of buttons that represent each element in the periodic table. And we have that data.elements dict that has a lot of information about the elements and which groups and so on that they belong in. So we can use that to automatically populate this table of buttons. So we'll do for L in data.elements. We're going to create a QTool button, being sure that we have imported that, which we have not yet. So we're going to bring in a tool button, or we're going to create a tool button. The label on that button should be the element name. We're going to set it to be checkable. And then we want to get the color. And that's where we're going to use our elements dict and this set of colors that we've got up here to work that out. So we can do self.cm, and then we can do data.elements el and use block. And now we can color the button according to that by setting a style sheet. Well, that's one way to do it. So I'm going to just go like this, and so we can go to QTool button, and we'll do background. So this is a Qt style sheet. Let me see if I can pull up Qt style sheet. So there is a style sheet reference here, and so we're working with a button. Where can I find? I guess these are alphabetical, so if I just were to come down to Q tool button, oh no, that brings me right to the class. So it supports the box model. Let's see, what does box model mean? So that's about the different margins and things. But we can also style it. Okay, here's the list of properties. So you can set the background color and things like that using a style sheet, and you can change many other different things about the style. There's quite a few options here. But we're just going to change the background and the color. And we're also going to, so we'll set the default version for that and the checked version. So we'll do RGB. How do I want to do this? So I could do, so let's make this an F string. Will that work? No, it won't work because those are in there. We'll do it like this. So we'll do %i, %i, %i to insert some integers there. And then we will do, so we can semicolon there and then set the color, RGB. That's going to be the text color, not the background color. And now we can also do QTool button and then 2 colons and checked to change how we want the styling to be when it's checked. And in that case, we're going to do a heavy red border. Well, a heavy reddish border. Okay, so now what we need to do at the end here is just tell it what we want those colors to be. And we'll take it from our RGB tuple. Okay, I think that should work. So now the row, let's see, so we have in our data.elements, we can get the period for that element, and we can get the column as the element group. And now if the series is greater than 8, we're going to set the row to be the series. Okay, so now, because we're using this grid layout, we can do self.layout.addWidget, and we're going to add the widget we call B up above to the row and column we just worked out. And we're going to say b.toggled.connect. And we're going to do, we're going to use this partial thing. So do we need to do that? We could just do, yeah, all right, we'll do it this way. Update element, so we're going to need to create an update element function, and we're going to, so we need to bring in, we might need that later. From func_tools, import partial. And now we create another function called update element. It's going to take the element and a Boolean state. So this partial creates a partial sort of function out of this update element. So it binds the element that we currently have in this loop to the function, and then takes the Boolean from this connection as a parameter when it calls this function that it's connected to. So now we're going to do self.elements equals el, or el in self.elements if el not equal element. So what that is doing in effect is it's removing this current element from our list of elements. And then if this b parameter is true, that means that we're going to add the element back in. So we'll do self.elements.append element. And then that's where we can emit our signal. Okay, so what I'm going to do now is I'm going to come in here and I'm going to do self.pt.changed.connect. And I'm just going to print self.pt.elements. Let's see what that does for us. We've done a lot of coding already and haven't really checked if anything works, so let's see. So right off the bat, it looks like we have a problem. Tuple index out of range. Okay, so do you see what I've done here? So I did 0, 1, and 3, but of course that should be a 2. 0, 1, and 2. And it's still not showing up, so we've got another problem. Self.layout. So that should have square brackets. Or not square brackets, it should have brackets. So where was that? That was line 70. Should be. So let's come back here, line 70. So right here, that needed some round brackets. I forgot those. And oh, good news. So now we have got this new action in our sidebar, and if I click it, I have a periodic table. And as I change my selection on it, you can see that it's printing the list of selected elements. So that is all working just fine. Now we need to add in the table and a plot. So let's get started on that. So the way that I wanted to do this was that I want to add this, but now I'm going to put the table, so I can get rid of that. I'm going to put the plot in the table in a splitter. So let's do splitter equals qsplitter, and it's going to be a vertical splitter. So remembering that we've got to bring in qsplitter. We're also going to bring in a bit more stuff. So we're going to need QTable widget, QTable widget item. Okay, so we've got this. Oh, and have I not brought in? Yeah, so I'm going to need that as well. Okay, so we've got the splitter now, and we're going to do a, so we'll do self.rm table, oops, table equals QTable widget, and we're going to do self.plot equals plot. Now we'll do splitter.add widget, self.rm table, and splitter.add widget self.plot, and we'll do self.layout.add widget splitter, and let's see if that resembles what we were hoping for. So we've got a problem. Self not defined. Okay, I did a capital S there. That's a typo on my part. Right here. Back in business. Okay, so that actually is a good first start here. So we've got the table and the plot are in a splitter. I want this periodic table to be up at the top for some reason. So I'm going to come back here and I'm going to do, I think it's self.layout.setAlignment. And I can tell it the widget, and then I can tell it that I want to do align it at the top. So I just want to make sure that works before we move on. There. So now, what do we need to do? So when we change our element selection, we need to add the matching reference materials into the table and into the plot. So let's get doing that. So we're going to create some new functions in here. So we'll do update RMs. So we'll do self.rmTable.clear. So that'll take everything out of the table that was there. And if the length of our elements list is 0, we could just return. There's nothing else to do then. Now we need to look at which reference materials have all of the elements that we've currently selected. So we're going to do for rm name in data.referenceMaterialNames. And now we need a way to check if the reference material data for this reference material has that element in it. So we'll do if all, so we're going to do el, so element in data.reference material data rm name, or el in self.pt.elements. Then matches.append rm name. So let's just see that works. So now what I'm going to do here is I'm going to do self.pt.changed, and I'm going to connect to self.updateRMs. Not sure which reference materials I have loaded on this machine, but let's just, so I've just selected sodium, and you can see that it's matched a bunch of glasses and things. Let me see if I pick gold, then you can see some of them fall out. If I pick something even more exotic, yeah. So I would say that that is working as expected. So we're getting the correct reference materials matches. Now we want to, so we're going to have a table where each row is a different reference material and each column is a different element. So on our table we can set the row count to be the length of our matches array, and we can do set column count to be the length of our list of elements. +1, right? Because we're also going to want to have one of the columns be the reference material name. So the number of columns will be the number of elements +1 for the name. So that should do that. Now we just need to iterate through each of our matches. And I'm going to do that using this enumerate thing that allows me to get each match out of matches, but also an index, and that'll allow me to index things in the table. So I could do now self.rm table.set item, and now this set item takes a row and a column, and then the third parameter is a QTableWidget item. So the row here is going to be this mi, the column is going to be 0, and what I'm going to put here is the match. So that will be the reference material name. That will go in the first column and it'll go in the row of that match. So have I already brought it? Okay, I did already import that. Okay, so that's the name taken care of. Now we're going to need to go through each element, and I'm going to use the same trick here. So now we'll do self.rm table.add item, and now the row again is going to be the same row from above. So I'm going to go mi here, and then for the column index I'll do ei +1. So that's the element index +1, so that we have the space for the reference material name. Now we'll do that table widget item, and what we're going to want to display is going to be so we need to get the reference material data for our match and that element, and then that is a result value, result object. So we're going to do value in ppm, and then we'll try to put enough brackets to make everything happy. Now that's going to be a floating point value, so I think that we're also going to need to wrap that in, string, so that we don't get any errors there. Okay, let's try that. So sodium, looks like it's not working. QTableWidget has no attribute named add item. Oh, that's because it's supposed to be set item. I save that? Yes. Okay, so let's refresh. Sodium. Okay. So we've got our reference material names and the concentration in ppm, but we haven't set the headers. So the way that we do that is we can come down here. So I suppose right here should be fine. So we'll do self.rm table.set horizontal header labels, and then that's going to be name plus, and I'm going to do something like this where it's going to take the element and add ppm on it, and then I'll do for L in self.pt.elements. Okay, so that's that. And I can do self.rm names equals matches, just to keep track of what RM names are being used, because we can potentially reuse that information when we update the plot rather than have to work that out again. Let's just make sure that that last change worked. So now you can see that we have sodium, ppm, and name in the header. So the table is more or less working. Now is the plot. So let's see about doing the plot. So we can do another function, update plot, and we will connect that to the elements being changed as well. And what we're going to do here is self.clear plottables, because we're not going to do it as a graph this time. We're going to do it as a bar chart. So we'll do clear plottables instead of clear graphs. And we need X positions, so we can do numpy a range in there. So we'll use that RM names that we just stored up above. Because the update RMs will be called before update plot, that should always be up to date for us here. We're going to want to make sure that that is a floating point type. Okay, so that's our X values. Now we're going to do one of these for loops to iterate over each of the elements. And now in this case, so we need to get the Y data, and the Y data are going to be similar to what we did above, so we can just gather this all at once. So we'll go, what do we need to do? We need to do data.reference material data for the RM name. Wait, right, so RM name, yep. And the current element, and we're going to get the value in ppm for RM name in self.rm name. So this is going to be the concentration, so Y will be the concentration of the current element for each of the reference materials, and we're going to have that be a numpy array. Okay. Now we can do self.plot.add bars, and just you may need to update to the most recent version of iolite to get some of these features that I'm doing with the bar plot. So that we'll add that, and then we can do a couple of things with the bar chart. So let's just start with this. Just so we can see where we're at. So let's do self.plot.rescale axes and self.plot.replot, and let's just see what happens. Okay, so nothing. Clear plottables QWidget. Oh, so what I forgot to do there is I forgot to include the plot. Okay, so right now that's showing us the concentrations of sodium for each of the groups that match, but just out of curiosity, right, so now if I select another element and another element, they're all just going to plot on top of each other. So ideally what we want to do is have these all plot not on top of each other, and potentially with a different color. And also we would like to have some labels on the bottom here. So let's get doing that. So one thing we can do is we can do self.plot.left, set label, concentration, ppm, and we can do self.plot.bottom, set ticks, x. So let's just make sure that was fine. So now we've got a label there and a label there. That's good. Okay. But we can create some bar groups. So we're going to do, so back up here, we're going to do a little bit more setup on this plot. So we're going to do self.plot.set legend visible true. So that way we can see which color belongs with which element. We're going to do set legend alignment, align top, and qt.align left. We'll do self.plot.bottom. We can set the tick rotation to be 90. And we can do self.barsGroup equals QCP bars group. And we'll need to bring in that QCP bars group. And we're also going to bring in QCP color gradient. So down here, we'll also create a self.colorGrad equals QCP color gradient. And we'll do spectrum as the gradient preset. Now, down here, we can set the bars group of this current bar plot to be the one that we created above, self.barsGroup. And then we can set the width of this bar to be scaled depending on the number of elements that we're plotting. And we can set the we'll set the brush of the current bar depending on a color that we get from our gradient that we created just above. Okay, we need to bring in QBrush. And then the last thing we need to do is tell it the name to use. Let's see how that is looking and whether we have any errors. Okay. That's looking pretty reasonable, I think. All right, yeah, I think that's looking pretty good. The only thing that I might just go and do is to also change the pen. Not that it matters too much. So the pen is blue on all of these. So we could do b.pen. Probably just do set that to the color, and we'll set the pen to the color. And oh, we got a problem. Oh, of course. So lastly, we'll bring in the Q pen. Let's select a few things, maybe set it to logarithmic. Yes, I think that we're in business here now. Looks good. I think that that's pretty much everything that I wanted to do for this example. So we'll end it there. Okay, so to summarize, a UI plugin only has one required function called create UI elements. That function is called when the main window is initialized, and it should create menu items, dock, and/or sidebar widgets. A UI plugin can access, modify, and create all kinds of iolite data, meaning there are endless possibilities. This week's assignment is to create your own UI plugin. So I've included a few ideas here, but really this is your chance to come up with your own idea for something that would improve your workflow or solve a problem that is unique to your situation. A few of the ideas I had were to adapt your spider diagram image inspector, if you made one 2 weeks ago, into a UI plugin that responds to the active selection rather than an ROI, or create a spline explorer. For this, I was thinking you could select a channel and group and then display the splines generated for each spline type. This would allow you to see how similar or different they are. Note that there is a function, data.spline, that you can use to calculate the splines. Or you could create some shortcuts for selection manipulation. This sort of thing can be very handy, and I've made some suggestions here. So you could create one to split a selection in half, which would be similar to the example we did today. You could create one that joins the active selection with the nearest selection, or you could create one that aligns the active selection with nearby data. Remember to have fun and let us know if you have any questions or problems before you get too frustrated. So that concludes iolite's Python for LA-ICP-MS course. We hope you enjoyed it. Please send us your feedback and let us know if there's anything you would like to see covered in more detail. Bye for now.